Okay, my name is Tim Riker. I previously have been known for many things, so I'll just give you a little bit of summary. I've been a Debian developer, but not very active lately. I maintain a game called BC Fly, which many of you may have played or heard of. That was on Depth Fly. I formerly worked for Caldera before they became the Eagle Scout. And then I was the CTO at a company called Linio that did embedded Linux development before they became just another group of people that worked for Motorola. I was the CTO at a company called Sagas, where I built an Android-based phone, which I'm carrying with me. I've been using for a year now, but I don't have anything to sell you, so that doesn't do you any good. We are officially approved by Verizon. If you go to Verizon's Open Development Initiative wholesale site, you'll actually see pictures of the phone. You can get an email contact, which will probably eventually end up in my inbox. I gave the keynote last year on Android and some of the issues with it politically in getting a device off the market. This session is basically an introduction to Android development. I'm going to talk about, but probably not show you, Android individual application development. But I'm going to talk about building the operating system itself. Actually have we'll get to this a little later on in the discussion, but I meant to get my USB stick out in just a second. Okay, maybe I'll find that, maybe I won't. In order to get started in Android development, which I'm going to get through a little later on in the presentation, you need to download a little bit of software, which includes the Android SDK and about 8 gigabytes worth of Git repository, which probably on the wireless here won't be practical for you to do at the moment. Sorry, I'm going to do this as soon as I get my laptop working, and then I do my laptop anymore. So I have a USB stick that has a tarball split in two of the 8.1 gigabyte worth of download if somebody wants to start playing with this. And this is basically CyanogenMod, which is a port of the Android, or a community project built around the Android operating system. So does anyone want to volunteer to start off with this? There are 2 tarballs in the root directory. You need to either concatenate them together and unpack them once you've concatenated them, or run them through a pipe and do the same kind of thing. I'll talk about that one later on. But if you can figure it out, then it saves you 8.1 gigabytes for the download. Android development. Let's talk a little bit about Android history. Android is currently a project that Google runs for many mobile phones. I'm sure you have to be living in the dark and are not heard about it. Some of the history, though. Android started as a company primarily founded by Andy Rubin, who was formerly the key developer and founder of a company called Danger Incorporated. Danger built a product which they called the Hip-Hop, which many people have not heard of by that name, but the T-Mobile Sidekick is the product as it was eventually commercialized. This is basically a cell phone hardware device that was not designed to be used as a cell phone. It was designed exclusively to be used as a messaging device or an SMS, MMS messaging, etc. Eventually, some of the sidekicks gained phone capability, but the original version as it was released was only messaging and internet access, and the idea was that I think there's no reason why it couldn't have been a phone other than having a mic. But it wasn't because it was supposed to be opening this new market space. Andy was the primary motivation behind building this kind of a device. After leaving Danger with T-Mobile taking it over and basically selling and building the product themselves, he and one of the executives from T-Mobile, whose name I don't remember, but Wikipedia will tell you, and 2 of the other, I think, lead developers that worked on Danger went with him and started Android Incorporated. From 2003 through really 2006, this was an unpublished group. Anybody remember the really old kernel days when Linux used to work for a company called Transmeta, and all you go for the website for Transmeta was like one page, didn't tell you anything about what they did. Yeah, this is the kind of mode that Android was in. Go to archive.org and search for look for anywhere during like 2004 for the homepage for Android.com. You'll see a picture picture of an Android face and nothing else. And that's basically their market presence. Somehow Google figured out what they were doing, got in the conversations, I'm not privy to any of that, and acquired them in 2005, and still didn't announce more or less what they were going to do. In 2007, November 5th, 2007, the Open Handheld Environment, the quotes are my own, was established by a group of primarily, well, there's a mix. There were manufacturers, there were carriers, and Google all involved in this Open Handheld Alliance, which no one could join, and no one would tell what they do, and they hadn't released any public specs at this point, and they hadn't promised to release any public specs or any public code, but for some reason it was open. I know because I tried to join it and was told there's no entry for joining. Anyway, after the Open Handheld Alliance launch in 2007, 2008, T-Mobile released this G1, which was...
Get a question back.
So, yeah, I was part of the OHA as part of my life company. We don't do anything. So, there's nothing to worry about.
So I'm not missing anything.
You're not missing anything.
All right, excellent. So some things always happen because Android was still in active development. The rumor mill, mostly, there's nothing confirmed publicly that I'm able to find, but the rumor mill is that Android Incorporated was already building the Java Stack mobile phone platform before they were acquired from Google. It's a little fuzzy as to whether they picked Linux or OS, or if they were working on UI issues, or how much the architecture government is on. But the wheels were in motion for some group. I don't know. The Open Handheld Alliance, was that just in name? I don't know. I wasn't internal, so I just tell you what I read in rumors. Go read the internet, get your own rumors. Anyway, 2008, the first Android device shipped, the T-Mobile G1. This is a device made by the HTC, also known as the HTC Dream. And it was a fairly full-featured mobile phone as compared to other phones on the market. Anybody give me any a few things the G1 did that other phones on the market didn't do? Anybody? The popular phone at the time was the iPhone. There were other Windows Mobile and other popular phones. The Android phone, the things that I can think of, had an accelerometer, which not many phones had, but the iPhone did. Had a digital compass, which to my knowledge no other production phone in the US had a digital compass in it. I personally don't find it a very useful feature, but that's a different point. Had hardware and assisted GPS, which is kind of new. There were some HTC phones running Windows Mobile that had that, some didn't. But Android basically brought together all of these features in one. It had a slide-out keyboard, and a half-TV display, and it was a color screen, it was a multi-touch capable screen. The original drivers were on a single touch. So it was relatively significant as far as feature set, but not, we've gone all the way since then, right? It's a half PGA. About 400. I'm trying to think of the right acronyms. Anyway, 320 by 400, whatever that acronym is. Display. Anyway. Open source releases, I'm going to talk a little bit about that. So, between 2007, the formation of the Open Handheld Alliance, and the T-Mobile G1 release, there was the release of a beta SDK. The beta SDK for Android went through a number of revisions before the G1 was released, and one revision basically immediately after the G1 was released, which was the 1.0 version. And so the developers kind of got a clue as to what was going on internally. And it's open source. If you look at my keynote last year, this is one slide to cover that, okay? It's Linux, except it's not. It's Java, but it's not. It's Android Market, which is not open source. So it's open source, but it's not. The Linux kernel is used on an Android platform. The C library that's used is a derivative of the Linux. My light goes off, turn it off and back on, goes off immediately. People in the back hear me okay if I just talk loudly? I'll just talk loudly. Somebody's recording this. I'm sorry. So Android uses the Linux kernel, but it builds on top of that with its own C library called Bionic, which is a derivative of the FreeBSD library. It does some things in user space, which I'll talk about in more detail in just a minute. But then it uses Java language to program most applications. There's an indicator, exceptions, but primarily it's a Java development environment. But we run through the Java compiler to generate Java's P code, which is the translatable code. And then the JDK, or the SDK for Android, converts that into its own native code, and that's the code that goes down on the device. So there's no Java P code interpreter on an Android phone. So has anybody ever written an MIDP application? You know what that is? I can't remember what the acronym stands for. But there's a mobile standard for developing mobile devices on Java. It's called MIDP. Android is not that, and can't be that, because it doesn't have a bytecode interpreter. MIDP, there was an SSH client, there were a number of different applications available. You could run them on Palm devices, you could run them on Windows mobile devices. It was supposed to be a cross-platform, cross-mobile phone operating system that you would build for Java. Sun was pushing in this direction. In practice, difficult to achieve because buttons are laid out different on different devices. So soft buttons, hard buttons, what are you actually using, accelerometer, digital compass, GPS features, networking capabilities between the GSM and the CDMA device. All these things were not well encapsulated in the MIDP standard. As the standard moved through versions, more and more of those features became available. And Sun's promise was we will be writing Java applications that run on any platform. We didn't get there. Android is not that, but Android runs its own bytecode. I'm not a lawyer, but I'm going to mention this. There is currently a lawsuit in progress between the owners of Java, which used to be Sun, is now Oracle, and Google, talking about which of our patents are you talking about. Some of the patents that are involved in that conversation specifically deal with P code, which the Android device does not run, but uses as part of the build. So I can't speak for Google. Did they try and circumvent some of the patents then? Did they try, I don't know, the full motivation behind it, but anyway, it uses that kind of an architecture for good or for bad. Android architecture, there's an operating system here, the pieces I've been talking about, the OS. Different areas that you'll see on an Android device if you log into it. The Android boots up a kernel that includes an initial RAM disk. That initial RAM disk gets mounted as root. On your normal desktop environment, that RAM disk goes away, and the root file system replaces it. On Android, that doesn't happen. The root file system stays there, and all of the system binaries live under /system, and that mount point stays there for the duration that your phone is on. There's also a mount point for /data, which is where all your user data goes. That's application stored local data, as well as information about you, your contacts, your mailing list, those, phone directories, those kinds of things. SD card is mounted on /SD card. Unlike your desktop environment, which probably mounts things that are /media/volume name, Android is currently hard-coded to /SD card. This makes it difficult if you have a device like mine that is a USB host port, and you plug a hub in and stick 4 USB devices in. Where does it mount? Good question. So Android doesn't have some scaling issues as far as being a full desktop environment. It's a mix of native and Java. Some of the native applications that you run on your phone are built just like you would normally build them through the SDK, which is what we're going to talk about next. Some of them are actual application binaries. So there's, on many embedded systems, there's a tool called BusyBox that you run that has all these different Unix binaries encapsulated in one binary. On the Android platform, there's a program called Toolbox that does almost the same thing, written from a totally different code base, running only on top of this PHP library. It has a bunch of different binaries from it, and it's compiled as a native device. So you've got an x86 Android platform, it's an x86 binary, you've got ARMs, ARM5, it's an ARM5, again, ARM7, it's an ARM7. And the Dalvik JVM is one of those applications, runs as a native, and then interprets the rest of the Java environment. The Java environment includes things that you might think are built in. If you're running like a Windows phone, the home screen that comes up when you initially boot your phone, that is a native compiled Windows application. You can't replace that. On Android, that's not true. Most of the system services are designed to be replaceable. So your launcher that initially comes up might be something like HTC Sense, which is their customized view. It has a different scroll bar across the bottom. The apps show up in a different way. The settings are a little bit different. And you can go to the Android market and download something like ADW launcher and replace your built-in launcher. And then when you hit the home button on your phone, you get a choice to pick between the Sense that's built in or the one that you just downloaded. And you can switch back and forth between these two different home screens. And when you decide you like one, you can click a little button that says make my selection permanent. And now when you hit the home button, it will automatically launch ADW instead of your HTC Sense, for example. You can do that with the email application, you can do that with the web browser, you can do that with the talk app, chat application, messaging app. Many of these features are published as normal services and can be replaced on Android. We'll talk about Android app architecture in just a minute. Anyway, so that's your stack. Your kernel file systems is on top of that. You got native binaries, native libraries, your Dalvik JVM sitting on top of that, interpreting most of your downloaded applications. In order to build an application, and there's good tutorials right on developer.android.com. So I'm not going to cover this in a lot of detail, but here's the basic idea. You install an APK. The APK basically incorporates everything in your application. It's bundled up into one, effectively think of it as a tarball or a zip file. That's effectively what it is. And it has a manifest, like a jar file would have under Java. There's a description of what the app is, its title, and all those kinds of things. And it also describes the components of the application. The application is driven by windows that you see on the screen. In Android speak, these are called activities. And an activity is when I launch my email browser, it comes up with a list of all my mail messages. That's one activity. The screen where I enter different accounts is a different activity. And an application is just a collection of all those activities that drive in between them. Android works in this way. The view is each of the subpages within that. So any individual layer is called a view, and the activity is moving between each of them. Widgets are like you see widgets on other operating systems, the text, and then a drop down, whatever. Those are widgets that can show up on multiple activities or multiple views in your application. As I mentioned, so launching an application starts an activity. That's not really a hard, fast requirement, but Android has a pretty, it's kind of undocumented what happens with an application that doesn't launch an activity. So that's the norm, that's the way to go. There are exceptions to that. Everything in this talk, I'll stay away from the exceptions. So you launch an application, an activity comes up. An application can present a service. A service is something there for an extended period of time. So let's say I'm building a client that knows how to talk on AOL's instant messenger network. Well, I would want this application to continue to be running on the system and not get serialized to temporary storage because it wants to listen for a network connection. So it will present that type of functionality as a service. Now, it may also have views as part of activities that would be only resident involvement of all the devices on the screen. But Android tries to isolate those so that the network services can be running continually on the machine, whereas the activities are only used when the user is actually looking at the page. There are content providers, which is commonly implemented by something that uses local storage for SQL. So let's say I downloaded an ebook reader and I pulled out an ebook, or add more content, maybe a local database of content that I can pull on chapters and have in my book. It's likely those books or chapters will be stored in an SQL-like database. The SQL-like libraries are included right in Android. And when you pull down individual content pieces, you can stick that in content. Now, there's an interface that supports all of this. It's not a full SQL-like interface. If you want to build your own, for example, dynamic content parser that you might want to build before you populate your SQL-like database. The SQL-like instance in Android doesn't really support that add-on functionality of building a separate parser because it's not exposed in the Android API. It is exposed in the C-level library. If you are a native application, the normalized decay encourages you to write to the Java API, which doesn't expose that specific feature. Broadcast receiver is something that you want to be able to respond to, typically a network event. So you could also write your instant messenger as a broadcast receiver, in which case it could be completely serialized to disk. The OS would know an incoming connection on port whatever means wake that thing up and let it show you the message. So there are a number of different ways of doing like background applications. Broadcast receiver is one of those standard ways. To do development on Android, and here's the bit where I'm going over the same thing you're going to find in Android.developer.com. There are SDK releases that you download to do application development. Part of what you download is a Google driver for your phone or for your device. This includes a program called ADB. There's a bunch of others that do screen capture and things like that. But ADB is what I'm going to focus on. ADB will give you a list of all the devices attached to your machine, whether they're emulators or real hardware plugged in with a USB port, for example. It's even possible to do ADB connections to a device over a Wi-Fi network. So you can set up your phone over here to listen on port whatever. It's also on my laptop to talk to port whatever on that IP address. And I've got a connection to ADB running over there on the phone. ADB allows me to do things at the lower level, like pushing files on the file system, which is not in the system or the root partition, but in the data partition where the user has access to, typically, again, exceptions. But normally, then you only can write to those user level access in the system. If you have a developer phone, typically you'll have root level access. So from that ADB connection, you can write to other parts of the file system. You can remount your system to read only and things like this. Most phones, when you buy them from the retailer, come locked down. So your ADB connection is only running as a normal user, and you can only write to areas that the user will be allowed to connect to. You need a JDK. Obviously, you can run Eclipse. You can build things. Eclipse is the supported IDE that ADT runs under. ADT is the Android development tools. That's what's published by Google. And it will plug into Eclipse. There are people who also run other JVM IDEs. Java IDE, I can't think of some of the commercial ones. There are people who use NetBeans for development. That's not what I was thinking of. I was thinking of commercial replacement. Similar to Eclipse. That's what I guess they're not putting into my slide. But Eclipse is not the only option for IDEs that can do integrated graphical development of Java applications, but it is a free one, and it's probably the most popular. You can do application development on Linux or on Windows or on OS X. There's no hard requirement of 32-bit versus 64-bit, whatever platform you're on. This should all work. Android, Google released recently, a year and a half, maybe 2 years ago now, so not that recently, released what they call an NDK. An NDK is a native development kit. And the native development kit currently only supports ARM 5 and 7. So if you happen to be running Android on an x86 device, anything built in the NDK won't run there. Same if you're running on a MIPS device, there's a MIPS port of Android. But most of the devices that are in the market are ARM 5 or ARM 7. So what this means is, remember I told you about the APK, it's basically your application. Inside the APK, there are specific paths where you can put native shared libraries that you find out on the Linux environment. And your app can call the libraries from that path. So if you've got an application, say Easy Flag, that's written mostly in C++, and you don't want to rewrite the entire thing in Java, in theory, you can build that whole application to run as a native binary and link its screen display to a Java wrapper that just instantiates a view inside an activity with one big graphical thing that says draw here. And so I've seen at one point there was a Doom port floating around, and that's exactly what that was. Recode Doom, they just took Doom, the C binary, built it inside of a package, and put a Java wrapper around it so it launches and takes over your whole phone. Now you lose some of the button capabilities, it's not the friendliest way to do things, but you may have legacy code that's easy to get out from your mobile platform by continuing to use the C or C++ code that they already have, whatever language it's written in. It could be a Python environment, it could be other things.
As the Android platform does not run the Java bytecode, what would you say is the performance cost of writing a well-designed Java application for Android versus those applications like native?
So we're to the language debates here. Most of the modern Android phones, when they, so the question was, what is the performance penalty? Because Android normally doesn't run native binaries. It runs virtual code, which is what you download in your package at. What's the difference between the performance of that versus the performance of indicating or re-implementing through the NDK as a native binary? Well, there's a lot of language debate, right? Is Java the most efficient? Is C the most efficient for your application? I'm going to avoid that. Most of the phones that are out there today in the market have a large cache for all the applications. So the first time you launch an application, you download it from the Android market, the system, the Dalvik environment tries to go through that effectively like a JIT and build a compiled version of that down to native code. And if the Dalvik code is in your handheld is implemented correctly, it will do that for ARM5 or ARM7. And so if your code is written efficiently, in theory, you've got a launching overhead in the first launch. And then after that, you're running close to native speed. So there are issues that can cause your cache not to work, and so parts of the application end up getting recompiled over and over as they're used. The cache isn't always coherent, and you can upgrade. So, you know, there are a lot of exceptions to that as well. But in most cases, you can run it near the native speeds. Yes?
So the Android NDK, is that basically a Java native library compiler? Is that what it does? Or is it actual native code?
It's actual native code. It expects you to put in C or assembly or C++, shared objects, throw them into your APK, and it provides a Java wrapper.
So it is that. So basically that's what the Java native compiler does. If you want to supply a library for Java, which is basically what you did there, you without C code, and then you export functions.
Right. So let's say, I'll give you an example of a sample application. Android includes, as part of its media player environment, a library set called OpenCore. And OpenCore understands a whole pile of different video and audio formats. It doesn't understand OGG, for example. It doesn't understand DivX for video. So if I wanted to ship a video player, I can go out and download DivX and legalities as a side point. I'm not telling you to do this in your own countries wherever you're living, because that maybe you may have to talk to corporations. Okay, but assuming you have all the legal issues taken care of, there are plenty of C and C++ libraries that will implement those codecs. And so you can take all of GStreamer, for example, compile that, stick it inside your APK, your larger APK, and call the native C interface, and then you get all the media files that GStreamer supports in your application. And still call through the system for OpenCore for the ones that it supports. And now you build a movie player that will be able to handle whatever you threw at it.
But you're still limited somewhere. Bottleneck is you have to use Java interface to do it. I'm not saying
so correct. So something at some point has to be written in Java.
Right.
Actually, somebody's probably reverse engineered how to throw that initial activity on the screen in native C code that I don't know. The normal interface that it expects is to open an APK and launch your effectively your jar. It's launching your methods within the Java functions that are going to draw that activity on the screen. But that activity could, as I said, just allocate the whole screen as an external display area. For example, what do we call them when we do the video? The term for that. The render, the thing that's throwing stuff on the screen.
Oh, the flinger.
The flinger, yes. That's all the flinger.
That's the actual technical term for the component in Android, basically the display compositor module. And that's something that I think it actually partially targets I think it does use GL to composite.
Again, depending on the hardware. Assuming the hardware has accelerated GL, the native flinger that's part of Android is the thing that's using that OpenGL hardware accelerator to just throw you out on the screen. So you can bypass all the Java implementation and call the flinger from your C library after you go to the widget. I took the whole screen as my draw area. I call it the flinger, and I give it an external program that's going to fling stuff to the screen.
It's vaguely equivalent to Wayland, where some parts of Nextdoor and Office put together.
Agreed. Similar. So, if you build an application that uses the Android NDK, obviously you're tied to the platform of the device. So, there's an x86 tablet out there running Android, and you've built an Android application that's in the market, it's not going to work on that x86 platform because the NDK doesn't support it. The NDK only supports ARM. Remains to be seen whether you can buy that and have the x86 support yourself, because in theory all of it is open source. I don't know anyone that has done it yet, though. The only apps I've seen are demo apps kind of targeting for a certain market. So the company has a corporate email application or a corporate contacts database. They don't want to rewrite. They build it in the NDK and launch that out to their own force, rather than going through the market. Does anybody know of a device, of an application in the market that uses the NDK today? Probably true. Probably true. I've not looked at its implementation, but that's probably true. Yeah, I would expect that's true. I'll try it out. Yes.
So, with Android 23, EBird supports NDK activities, so you don't have to go through Java.
Okay. I'm not trying that. So that's true. 3.0 as well, I guess, then?
I would assume. But it's only something pretty about that.
This comment was that in 2.3 and up, the Android environment keeps revving. There is an interface for doing native Flickr instances from the NDK.
Is native development being well received? Is it norm, or is it like a small subset of the application developers?
Well, I mean, ideally, if everything works, you don't know, right? The application you downloaded may be native or maybe Java. The question is it well received? I haven't gone unpacking APKs to find out. When the APK first came out, a few months afterwards, I did go poking around to see if anybody's using it. I talked to developers who tried it, but I didn't know at the time of any commercial application using it. It's been out for 2 years now, so I would think there are apps out there that are using it that I actively don't know. All right. If you want to learn more about application development, go to developer.android.com. We're going to jump to OS development now. So Android is supposed to be open source. The things that I want to do with it, it doesn't often have built-in. I can give you a long list of pet peeves. I'll pick one at the moment. Many of the newer cellular networks support IPv6 natively. Android does not support IPv6 on a modem device. This is one of the things I like to play around with. Android does support IPv6 on the Wi-Fi, although it doesn't support DNS lookups over IPv6, so it's kind of broken. But if I wanted to work on this, I can't release an app that adds IPv6 capabilities to Android. That's not a service that I can overload. So if there are things you want to do that an app can't do, the next thing you do is get involved in operating system development. Google releases, in most cases, the snapshots for the OS that's getting built on devices. Although these releases don't always include proprietary bits that you may need to get them running on the device. The releases lag after real release. So when the G1, for example, that I talked about, was released in 2008 in November, the open source release for that, I can't remember the date, was I don't remember exactly. It seems to me it was mid-February or something in the fall of the year. So it was like 3 months behind. And at that point, Google released the 1.0 version without some of the drivers to build it for the HTC. But they were pushing the G1 as an ADP1. So that was remedied actually shortly thereafter. You could rebuild an entire working Android build on top of your G1, replacing what you got on it if you bought it from Google. If you bought it from T-Mobile, it was supposed to be locked down. It was supposed to be able to be that. The community figured out how to get around that. CyanogenMod is currently one of the most popular of these operating system builds. The advantage of going to a community build like CyanogenMod is that you have direct contact with the developers, which you don't get from most of the Google developers. There are some Google developers that are very accessible. They're online on IRC, on Android, on IRC.freenode.net. They're on mailing lists, so some of them are easily accessible, some are not. CyanogenMod is very popular. It supports many devices. Also supports the emulator, which is included with the Android development tool that you download for Eclipse. Will launch the Android emulator tool. And you can just launch it, download cool tools, enter in that Android. And in that environment, you can download different drivers. So there have been different releases. There's Android 1.0, there's Android 1.5 is the oldest one that's currently supported. And there are some commercial devices on the market still running on 5. 1.6. 2.0 was the version of the Verizon, the Droid, Motorola Droid that shipped on Verizon, first shipped with. It was then replaced by 2.01 and then replaced by 2.1. Both 2.0 and 2.01 are deprecated, but they're still included in the driver development kit. So 2.0, 2.01, 2.1, 2.2, 2.3, 2.3.1. There's another 2.3, 2.3. There's one more 2.3 series. And then there's 3.0 and its family are the ones that are currently being built both different tablets. So when you download the Android tool, you can pick drivers for any one of these sets. You can get the basic Android requirement, which doesn't include the Google application interfaces, like maps and things like that. Or you can get the Google API version, which does include enough drivers to talk about, but in some cases not the application that you actually want to talk to, but you can build using the same APIs. In most cases, you can actually both pull down a sample file system image so that you can run that in an emulator, and it includes the emulator itself. The emulator is based on QDFU, included with the device. I say well for most things. The emulator doesn't support a camera, so if your application uses captured video, you can not even emulate that in the emulator. It doesn't support hardware GL, so if you're trying to run Angry Birds, you can't. It doesn't include the Android market, so you can't plug into the normal interfaces through the commercial interface and download applications onto the emulator. So if your device doesn't need any of those things, you can push an APK in the emulator and run it on a local instance. The OS builds use different tools than an application build. So there's a tool called repo, which is really just a wrapper mostly around get, and it allows you to pull out a profile, which is basically a definition of my project uses these 257, it's 259 now, these 259 different Git repositories, and then I run repo sync, and it automatically starts syncing each one of those, and it gives you an interface to sync more than one over time. I'll talk about the steps right here, I think. Let's jump right there. In order to build CyanogenMod from scratch, which is my tarball, passing around someplace to somebody on my USB stick. It's, like I said, 8 gig of data, so it's large. Officially, to build CyanogenMod, x86 Linux is a requirement. Specifically, Ubuntu is a platform that they prefer. So if you read the online docs, that's where they point you. I'm building on 32-bit Linux, which works, but the developer's screen. So if you run into problems, it's your own problem. OS X is also supported. I've not tried to CyanogenMod to build from source on OS X, but it is documented in the wiki. You need a bunch of native packages. Obviously, I installed SunJDK, I installed Get, other tools like that. They're listed right on the wiki, so I can list the specifics here. Install the Android SDK, which I got from Google. Install repo, which is just a wget, it's a shell script, and you pull it down, make it executable, then you do repo sync -j, however many things you want to sync at the same time. The recommended version up on the wiki tells you to do -j, I don't know, something large, 30 or something like that. If you're on a 1.5 megabyte DSL connection at home and you do -j30, all your other connectivity in your house is going to drop. Because the Git servers and GitHub is where most of the stuff is located, are very fast, and pulling down 30 simultaneous syncs from 30 different Git repositories will saturate a very large internet connection. I just re-downloaded as part of this to make sure I was most up to date, so I started over again. That was a mistake. It took me, I don't know if I timed it actually. I believe it took me 6 hours on my DSL connection to download this 8.1 gigabytes on that card. Then there's a step in here for running backups. When you build CyanogenMod, you can choose which, there's a program called Lunch, and you choose which platform you want to target. If you're targeting a device like, well, I'll stay away from which device. Numerous devices that are on the market have some proprietary bits that you need in order to be able to run them that are not open source, so they're not included in CyanogenMod. So there's a step in here that does backups. So you plug in your actual device over USB, you run that, extracts the proprietary bits, and it pulls the pieces that you've already licensed for use on your device off your device. And then when you build CyanogenMod in your local machine, it inserts those proprietary bits back into the file system images, so then when you flash them back to your device, you're not erasing the things that you've already paid for, you're just you're reloading them on your machine. That's often tools like, well, for example, the Google proprietary bits, right? So Android Market is one of the things that's in Android that you need of an Android device in order to install applications off the market, but Market itself is not open source, and it's not redistributable. So the only place it's licensed is on a device that you purchased that had a copy of it initially. So they pull it off that device, you reflash CyanogenMod, including that application being backed up, and now you still have Android Market, and you can still get applications for the market on your new ROM that you just built. There's a tool called ROM Manager, which is in the market, which is free but not open, which manages installing bootloaders on many different devices and manages downloading ROM images that other people have built different Cyanogen releases. There are modified versions that do overclocking your kernel, many other things that will violate your warranty. That's lots of fun. And it's currently a required part of CyanogenMod. Then you run a tool called Lunch. That shouldn't be an uppercase L, it should be lowercase L. Actually, you source a shell script. It's called build env setup.sh, and this loads a whole pile of effectively scripts in as predefined functions in your environment. So if you type set beforehand, you get, like me, this nice short list of just environment variables. Then you need to source this env setup, and now you have many pages of environments rolling past that are all effectively scripts. One of those is called Lunch, and what Lunch does is walks through your tree, finds all the different devices that this tree that you're working in currently supports, lets you pick one of those, and that will set the resolution to display, whether it supports SD card, and which set of packages are supposed to be built for this platform, those kinds of things, all get set up also in the environment. And then when you get to the next step, which is run MKA calls make with a bunch of other things that it sets up first. And it's one of those predefined environments. Then you sit back and watch it build. MKA will automatically take advantage of multi-cores. So there's no -J that gets passed in, although it effectively does the same like it calls make. It builds about 5 gigabytes worth of stuff, which includes compiling the kernel on some platforms. Actually, the 5 gigabyte number is for the building for the emulator, which doesn't include a kernel compile. So 5 gig is just building the application environment itself. And the target output of this is your RAM disk, your system, and your user data partitions that go down on the device. So you take those and you copy them in the case of the emulator, you just copy those IMG files into your Google Toolkit environment, calling it a new platform, and now you can, with this new Google Toolkit, define a device that uses those IMG files, and it will launch CyanogenMod in emulator. I think at this point, I'm actually going to try doing that. So I just rebooted, so something will break here. So let's start here. I'm going to launch the pilot. This is Eclipse, the integrated IDE. And I've installed the Google Toolkit into it. So if I go up here under Windows, let's see how I show my plugins. I'm not going to go there. But there's steps to install it in here. I'm going to skip that. But if I launch the Android SDK, we'll read this. For some reason it keeps forgetting where I got my toolkit. So Since Android, that's where my SDK is installed. You can see the different platforms I have supported. different platforms, so I still have 1.6 installed, I have 2.3, 2.31. 2.31 is actually more obsolete. The current version of Cyanogen mod is using that binary interface, so that's what I've been testing with. It's called API 9. I have two of them here because one of them is my Cyanogen mod that I built. Here are available packages, and there are third-party apps, including hardware support for some of the platforms. No, I guess actually all the Google APIs. Here are like LG and Samsung and various manufacturers that plug in some of the pieces that they want you to use for their own customized version of Android. If you're targeting the Galaxy tablet alone, you would use those extensions because you built just against the Google API. Some of the extra widgets the Galaxy tab uses are not available to you through Google's interface. So that exposes the Samsung proprietary bits. In this device, I have virtual devices, and I've created one. So here is a Cyanogen mod. This is the 231 kernel, which is API 9. That's my lame name that I have there. And I actually start this as a, let me see if I'm going to scale up here. Oh, did I scale it too far? Let's go. Let's start over. Should check that the right resolution before I launch this. Not too good. Okay, you get the idea. You can't see the bottom of the screen. But basically what's happening now is I've launched an emulator, which is QEMU, and it's running bootloader that's built in the Google version of the emulator, and that's the text you see on the screen. And it's starting to load the kernel, which we don't see in the boot screen from the kernel. Now you see the flashing Android, we're actually booting Android. And so Android is loaded up, the kernel's running, it's running through some normal file system mounts and checks, and looking at the cache environment, looking at the user data, and all that kind of stuff. Android takes a long time to boot. By the way, there are some initiatives in the, what's Tim Riker's in the Self initiative. There are some companies working on hibernation, basically support for Android. So when you download a new ROM image, it would boot the machine up to a certain point and then take a snapshot of flash. And so when you normally boot your device, other than an OS upgrade, it would be reloading itself from its saved hibernated state and then finishing the boot, which is all proprietary bits about finding out what network it's on, those kinds of things. So in theory, it takes this boot time down significantly from what you just saw. The emulator runs typically slower than a native device, but it moves around and you can go around. So I've built one of the steps we just went through, which is you've got the stuff unpacked, you should be able to do. I should point to the thing. Those of you who unpacked.
I just stuck those two tar files together, and there seems to be an issue with the second one. When I just run, they're just meant to be concatenated,
They're
right?
meant to be concatenated.
Okay, that's what I did. I checked the MD5 sums to make sure they both came over properly. And then when I just do a tar table of contents, it goes to the first one nicely, and then when it gets the second one, I get a bunch of header skip, and then it fails.
I had the same problem.
The same problem?
It's probably the key.
I tried it before I brought that key. The key may have been the problem. You can start your 8.1 gateway from download if you want. I think you're online. We're not going to get through that today. Let's see if I've got an easy answer for that. I've got that tarball here on my laptop. I don't know if I'm running the web server. Let me try it.
have a single toggle.
Yes.
Can we do an MD5 some of it just for the heck?
Sued. Doesn't want to go south and south. There you go.
Is that uneven for us?
Yes. Most everything that's in it is already compressed.
Okay.
I didn't bother recompressing and compressing it. Yeah, I don't know how long it's going to take. Just started. You can make the IP address. 172.24.131.98. Just give it a try.
Yeah, it works.
Where is the refi sometime?
Problems I don't have.
My Wi-Fi's don't play with this for somebody. So you should see both that and the MD5. The MD5 hasn't filled in yet. All right, back to the emulator. So this works like Cyanogen mod installed would work on your native device. I drag across the screen, and then so it's a little awkward. I've got the normal buttons down here at the bottom of the screen. I launch my applications. There's a list of all the apps. My keyboard works, so if I open an emulator, JAWS, I can click JAWS. And because this is a development build, I should have root access. I do. First time you check SU in an emulated environment, you get a pop-up screen for the sudo permissions. You go to say yes, allow this, or deny this. I have already accepted that, so it's not asking me this time. And if I look at things like mount, you can see that here's my data, cache, system, file systems. It's really readable up there. There are some things that don't work here. If I go home and pick black wallpapers. On most devices, there will be an entry here for live wallpapers, which is like putting fish roaming around your desktop on a 3D screen using big accelerometer, a lot of apps like that. That feature is not turned on here in this hardware architecture because this hardware architecture doesn't support hardware 3D. But if you were to build for something like the G1, you would get a similar experience. The G1 actually does support hardware 3D, not as fast as most of the newer phones, but it does support it. But the reason they turn it off is because it's got very little flash space, so the image size, it doesn't include that part of the build. So you target that environment without the in wallpapers.
How much slower is the emulator?
It's probably about the same speed as a G1, which is about a quarter of the speed of the newer phones. So it's not too bad. The biggest issues are the screen refresh. So if you're running an application that's doing background processing and building an SQLite database, for example, things like that, it's relatively quick. But if you're doing something, if you try to run Angry Birds on Android Market, you have to exercise the student to figure out how to install Android Market on your emulator build. It is possible. But anyway, if you did, if you have an Angry Birds APK, which uses that Flinger, uses the hardware accelerated 3D layering a lot, it may not even run on this platform, and if it did, it would be unusable. Something like Labyrinth 3D displays a 3D maze on the screen and lets you move that around. That would also be really slow on this platform. We're only about to talk about halfway through. Yeah. I figured this would take you about an hour and a half. Does anybody else want to try this, or is it just failing? Not getting,
And combine those two files, the MD5 sum does not match.
no match whatsoever. So you managed to get all you can download?
No, I didn't download all of it. I just downloaded the MD5 that you put out there and compared it against what I got when I stuck the two
Okay.
files together. And then that was it.
Is the byte size the same?
Yes. Well,
Number? 839-727-14 or 1040.
ooh, you're off by one.
Off by 1 byte.
1039.
Missing a byte. Okay, so 4 gigabytes into this file, you lay down on the 1 character. All right, my apologies. So we were supposed to now be playing around with actually building CM on hopefully on two different machines, but we didn't get that. So let me take questions. If you want me to rant about anything in Android, just get me started, and I'll tell you what I'll do. All right, I'll tell you a little bit about that.
That was the word.
Android is a, in my opinion, all right, so I have a lot of opinions. So let me try and be, first of all, I'll try and be conservative in the comments. Android's an interesting approach to security. Each app that you install wants to be able to have its own database, right? And if you don't want to be able to pull down Joe Hacker's application and have it be able to read your email list and email all your friends, which is, you know, if you wanted to do that, you should be writing hacks for Outlook because that's easy there. But if you want to do it on a secure phone platform, the phone platform should prevent you from doing things like that. So the way that they addressed this issue was on a normal Linux desktop, one application that you run has full access to any other application you run. What Linux desktop environment and server environment does well is protecting that application from writing to the system. So if your browser gets infected, you don't own the browser. You're running the browser, but root owns the browser. So if your browser session is infected, you shut down and restart your browser, you're back to a clean browser again. On Android, that's not enough, right? Because you install Evolution and you install Thunderbird, and they can see each other's data and import each other's data. That's fine in your desktop environment when, in theory, you're supposed to understand what that means from a security risk perspective and not do anything you want to do in the first place. But when you're downloading Angry Birds from the market, and by the way, I don't work for Angry Birds or anything, it's just a popular game, so you know, run whatever game you want. It's just a popular one that I can refer to. So no, they get free publicity. It is a fun game. Anyway, so if you're downloading Angry Birds, and Angry Birds has a back door where you can go and read your email list and you start from your email application and start spamming all your friends while it's running, this is not the idea. No, it's not a good thing. So when you look at an application, let's see if I can show you from the emulator. If I go into the settings, menu, settings, and here I'll have a list of applications I'm running on my Legend phone. There's applications, manage applications, and no applications. No, it's not going to show me what's been built in. Oh, there we go. Here's ADW Launcher, which is the built-in launcher. Down on the bottom of the screen. I'm hoping it's going to show me permissions. It does, look at that. Okay, so there are a number of defined permissions built in Android that an app can have. These are basically managed as group bits. So every application that installs on my phone installs as its own user ID. It dynamically makes these up as I start pulling down applications from the market. Each of those users can be members of groups, and those groups map to permissions. So there's a group that owns the SD card. So there's one for storage, modifier, delete SD card contents. Any app that has that group bit set can read and write anywhere on the SD card. That includes things like changing a file to be hidden or not hidden, changing a file to be read-only or not read-only, deleting a file, deleting a directory tree. All of those things are provided by the mounted file system to the SD card. There's separate bits for personal information. There's a list of these that Each Android release we add more to the table. It's 20 something, 30 something, maybe different permissions that an app can request when it installs. When I install the application from the market, it asks me as a user, is it okay for me to grant this application those four permissions? And you say yes. And in the newer versions of Android, the Android market will then ask you, well, it won't ask you, but you can set, automatically upgrade this package. And as long as any future release of that same product doesn't change the permission bits it's requesting, it'll automatically apply the new updates when you get online and tell it to update the package. If it does ask for new permissions, it'll ask you again. It won't ask you for just the differences, it'll ask you the new list, which is kind of unclear what's different between that and the old one sometimes, but it's better than nothing. This is supposed to be a rant, right? Not a training, so let me get back to the rant. So the rant is that no other Linux platform runs this way. Right? If you run your Windows application server and you've got 5 different applications installed, they're all running as the web server user. You install Tomcat, JVM, and you're running a whole bunch of different WAR files. They're all running as the Tomcat users. There's no per application security model. So this is the thing that's not well tested. And add on top of it that all of these applications are trying to share the system resources like the screen, the microphone, the speakers. So if you're running an X environment and you log in one virtual console, and that's you switch to another virtual console, Linux tries to change the, okay, now you own the sound system, now you own the sound system. But in this environment, it's like X. Each application running on the system is trying to render the screen, change your GL context, change, and every time the app becomes the foreground and goes to the background, it's changing that. And it's not exclusive rights, right? At the top of the screen, there's this little tray that I can pull down. I can grab this and drag it down. And it shows me what's going on in my system. Any notifications are in this notification area. In this version, I can actually turn on and off my Wi-Fi and my GPS and those kinds of indications. That's what these are. As well as like adjusting the sound. This part of the screen is always there, no matter what application is running. So the application has to go through the flame to get permission fits, and there are significant, when we find them, we fix them. But there are significant security holes in Android with dealing with this because the applications, each running as a different user, are not supposed to be able to access the same things the other applications can, but they all need to access the same system resources in order to run the environment. So as a theoretical design, it's a beautiful thing. Let's put everything in its own user space and everything will be great. As an actual practice, because it's the only platform that's running this way, it's not well tested. It's a guaranteed there are going to be security issues. So that's one of my main rants. The other rant is emulation. As I'm not an emulator, I'm not a VM, I'm not a T code kind of guy. I've got a platform in my pocket, right? It's got a limited battery on it. I want it to last all day, all week if I can, all month, as long as possible. It's counterintuitive to me to build an environment that relies on compiling here to native code. When the server over there that I'm pulling from is going to ship 100,000 copies of this application to phones, well, okay, not just like this, but just like you might be running. It's only one of 10 floors, so it's better than that. But in most cases, mass volume products are all exactly the same. They're all going to compile to exactly the same binary. And they're going to do it 500,000 times on 500,000 different phones in the market. This is the wrong architecture. It should have happened on the server side once, and then ship that pre-optimized binary down to 500,000 phones, so that they don't have to use their battery power to compile things. So, I'm just not a fan. I see the point in being able to take P code from the developers. If the developer wants to upload one portable application to the market, and the market would say, oh, the x86, and on 5, and on 7, and the right resolutions, the right hardware features that this app is requesting, I'll compile that down to native and then put that in the market. But now my phone, which is an ARM7 device, is contacting the market and saying, give me that thing, and it's giving me the portable version. Well, you know I have ARM7. Give me the optimized version. I don't want the portable version. I don't need it. Doesn't matter. You want more rants? Let's get some questions. There are
apps that are based on broadcast screensaver architecture. Supposing you upgrade one app and haven't upgraded the others, how do you keep track of what's going to be compatible and what's going to work correctly together?
Good question. So the question is for something that implements the receiver portion of the services. If you've got multiple things depending on how you make sure that you can move from version to version. Does that capture what you're asking? So let me talk a little more about permissions, right? I mentioned that each application you install on your phone installs as a unique user ID and has access only to that. Well, that's not quite accurate. Each application signed by the same developer's key installs as the same user ID. So if I wrote an application that was nothing more than a service, and another application that I also signed that consumed that service and wanted to install both of them on the phone, there are a couple examples in the market that are like this. It's up to me as a developer to give a version way of interfacing between those two. And I haven't looked at the existing apps to see how they do it. But typically the way a service is consumed is a single APK that includes some GUI interfaces, some views, as well as a service that runs in the background. And so those two are managed by a single file, and you're always going to be in the same. That's not always the case. If you want to ship multiple apps that have access to the same data, you can. But it's up to you the version between, and Google doesn't really provide an interface for that. What Google does provide you is availability in the market. So when you upload an application, you can indicate, I need this resolution display, I need an accelerometer, I need a GPS. And people that have devices that don't fit that criteria won't be shown your application. They also provide you, as part of that download in the ADT, Google licensing module. And the licensing module is basically an interface that includes these lines of code or whatever it is in your app. And when your app starts up, that piece of code runs and contacts the Android market right then while it's running and verifies, here's my device ID or whatever, I forget exactly what it says. But here's your key. Is that key approved? And so you can actually enforce people won't be able to run your application if they haven't paid for the license while they're online. While they're offline, they can still copy your APK on another device if they have root. They can still run it. But if you're using the Google licensing module and you're online at the time you run that unlicensed application, it will phone home and find out it's unlicensed and refuse to run on different devices. So, and there is some versioning control in that interface. So I may be licensed to use version 4, but not version 5 on that application or something like that. But there's no real control for running services with different versions automatically. That's up to you.
So let me ask a question. So I'm developing some C code, kernel, and I want to run some user app like Team or something. And hopefully this gets installed as a data file in Android, so it's very different than Linux. Big project. Any sort of describes how you're supposed to change those data files so they can move together?
So the normal way of doing this is through Android development. So go to developer.android.com and follow the tutorial. But actually, in the links section, we put the links section up. Where's my slide? Here, the second one on the list is just /videos. There's a tutorial that walks you through building the flashlight application. It's the usual starter. So you build an activity, it launches on the screen, it turns the screen bright light, and then you hit back to close the application. It only takes a few minutes. You can install the Android APK and walk through that tutorial and build the app. But
I think my question was, I'm not trying to develop something for Android. Okay,
right. So if you follow the tutorial, it does all that from Eclipse. So you create a project file, you create your Java stores, and it writes all that in one directory. If you build it as part of the OS build, it's going to access that package information and build it from the command line. But you have either way of doing it, and it's kept in the Android specific project file definitions for that. So there's an XML file that defines your,
Yeah, but it's not application layer. It's trying to modify the Android source. And Android source it out in Android.mp files and so forth.
right?
And he was asking if there was any instructions on Google's website on how to modify those. It's somewhat of a complex process.
So for modifying the OS, not for building an application.
Yeah.
There's very little documentation on Google's site for modifying the OS. Mostly it's written source code. There's a lot of information about the API and how to consume that from the application. That's really where their focus is.
Yeah.
But if you're a manufacturer and you're trying to get Android running on your device, this documentation is scarce and often out of date. So the best support forums that you'll get replies from is joining things like the CyanogenMod IRC channel or a mailing list and asking there. There's quite a bit of information as far as the build procedure in the CyanogenMod wiki, talking about how to build. But again, it's kind of short on who was talking about doing the other platform fork, and they followed the procedures and they were doing it in the kernel the right way. I forget, someone up here was talking earlier today about, this is how you do it in platform build, and there's no real instructions that I'm aware of. This is how you do it in Android platform.
And I think the example I should say was like doing UDEV. UDEV
Right.
or something like that.
So if you wanted to include UDEV,
And not UDEV.
but it wouldn't be a bad thing. It would be different. So there are a number of people that have tried, for example, to rip OpenCore out of Android and replace it with GStreamer. What they're after is the support for the formats that OpenCore doesn't already support. There's no documentation on how to do that kind of changes. It's just, but the biggest thing in my mind is you download CyanogenMod, get that working, and all the sources there. So you can walk through in the emulator and watch exactly how things are currently working, plug your debug code in wherever you want. You can run it you can run your own applications under Eclipse, line by line, debugging with source code visible and registers and all that kind of stuff, variables, trace points, traps, etc. There's no OS level debugging tool. That's kind of up to you. If you replace the library's crashing without a memory or null pointer, there's nothing that really traps that. Android does include Logcat. I'll show you a little bit of ADB. So part of ADB is a tool called Logcat, and Logcat will show you the effectively syslog of what's going on with your device. An iPhone, I'm on. Try it right now. This is an Evo. I don't work for HTC. So I'll move that up. We'll show you some of the tools right from the debugger. What was that? Oh, so native debugging, we do a lot of things through Logcat. So basically you connect with ADB, check ADB Logcat on the device, and then you can watch the kernel messages, the application messages, the development messages, everything that's going on during the system startup through that remote hub. And so a lot of your library debugging, if you were doing that in the file system, can be writing out to the debug logs, and you can see that from Logcat. So that's a very useful tool. I have not actually tried. Has anybody here tried plugging GDB or something like that in and debugging the file system, at the lower level than what Eclipse normally does? In theory, you should be able to do that. You can get a remote console. You've got wireless connectivity. You've got numerous options that you should be able to run applications under GDB, but you've got this hybrid environment, right? So you're normally trying to test a C-level library that's got to be wrapped underneath the JVM. The JVM is a multi-threaded instance. And also multi-process effectively because it runs different user IDs for each task. So getting through the stack down to the point that you may want to see is difficult. The print key environment going off the syslog, I've done that much.
Yeah, but also, of course, Android console sucks, right? That's the nicest thing to say.
that's the other side of my rant, I should say. It's not elegant, but it's Linux. So, you know, if you want to influence the architecture, the solution is to get involved and push patches. Patches that you push to Google do actually show up on shipping phones a year or so later. Patches you push to Cyanogen mod will show up a week or so later. So if you're running modified builds, you can get things in there. There are a lot of features in Cyanogen mod that are not in the Google repository. There are some things that are there by design that Google won't accept. There are some things that Google just hasn't looked at. Google should pick up and try pushing harder, and Google get them accepted. There's a mix. So there are things inside Google still lags by about 3 months on commercial releases. So when you get a new phone or a new tablet comes out on 3.0, it'll be 3 or 4 months before you see a full open source environment of what you actually rebuild 3.0 at home. And then it'll be 24 hours later before CN has a Cyanogen module to work with 3.0. It's not quite 24 hours, but it's pretty darn close. The community picks up those releases from Google, folds them into the community builds very, very quickly. And if you're following the community build, you get, it's relatively painless. Somebody is going to do that version for you. Now, let's see if I can talk to my phone. Alright, should have tried this beforehand, I didn't, so maybe we'll break. I'm basically through the presentation, so if you want to get up and leave, you like food, and I don't feel like I'm holding you here, but if you want to hear, stay, continue to hear me rant, I'll ranting and talking. So, thank you for coming. Okay, so here I am running ADB. I just plugged in an HTC Evo phone, which is actually a phone without service, but it's on the Sprint network. So it's, you can't see it from there, but it's running here. If I run ADB devices, this shows me that I have an emulator running, and it also shows me that I have my Evo running. So if I do ADB, -D, and I should be able to give one of these. I've got shell. There's a -D, -R. This phone happens to be running the actual release from HTC. I just re-upgraded because I was testing their firmware. So I type things like uname and I get nothing back. I should be able to hit proc version. There you go. HTC kernel. There you go. I type SU and I get nothing. Permission denied. Which actually doesn't mean that permission was denied to run the instant binary. This is an interesting issue with all Android files. Because my path includes system xbin, and as the user that I'm logged in as, I don't have permission to read that path. So I couldn't even find out if there was an issue binary. So the error I get back is permission denied because I got permission denied to see if there's a binary, and this is interesting side effects. If I do the same thing on shell, right, so same thing, .adb devices, and I don't need to specify the -S if I only have one device connected. In this case, I have two. So I'm going to the emulator, and now I've got a shell in the emulator. You'll notice that now I'm running the root. Because I have Cyanogen, I'm building as a development environment. It normally gives ADB, it runs the ADB daemon. So in this case, the ADB daemon itself is running as root. and on the commercial device, ADB is only running as the user. So in this case, I can do things like mounting. So you'll see my system partition is mounted read only. Right? I can dash it over. And now I've got system on the drive. And root, so I can change whatever I want on the file system and read it the phone. On the real phone, when I installed the vendor's version, that's what the lockdown version of the phone is. I only got ADB access as a user, not as system. And so I can't do things like remount the file system, redrive, and change my phone permanently without the equivalent of jailbreaking, or you're rooting your phone, root access to your phone. There are other tools in the same directory. So I'm here actually to the advisory directory. Here's DEMS. This allows you to get a graphical view of your devices. So here I have the emulator attached. Here I have the PDW attached. You can see the logs down here. Nothing to read that log. But if I launch a new application here, you can see the logs going by. You get dogs, messages, whatever. Close the application. Those are active messages. On the command line, you can filter, or here in the filter box, you can limit which messages you want to see. So if you're only watching Dalvik or only watching your system library, you can get that view in here. You can also get a view of the device. So here I'm just doing a screen capture. This passes through ADB and reads the frame buffer. So that's what the front of my phone looks like. It's captured through DDM. So you've got interfaces, and these are published. So there are some automated debugging tools that will walk through the UI and automate debugging either locally on the system or remotely on the system. If you're building a device, there's an Android compatibility test suite that Google ships that uses these hooks to do automated deploy testing. So it deploys a sample application in the phone like it would from Eclipse. You build an environment and deploy it directly inside Eclipse, and then do line-by-line debugging. It uses that as an automated test, pushes test code over there that walks through the different UIs in the JVM, and reports whether it gets valid output. And it will walk through for hours on your phone, just churning through API tests, making sure your device you just built or your emulator environment you just built is compliant. And it's easy to do regression tests between different releases to see, well, what worked over there still works over here. So it'll try things like walking through all your different locales, wide language sets for English, German, French, whatever you define your set to have. It'll tell you which one's passed and which one's failed. It'll do things like, testing 80 times in the engine, times along, long times along. Can I push this kind of data into the database and get that back and create a table and draw on the screen? Can I do 3D acceleration? It walks through a very rich set of the interface. Unfortunately, that tool is not open source. The only way you get access to it is by signing up with Google and telling them you're a device vendor, and they'll give you access to it. I've pushed on the Sanogen folks to get them access. I know some of them have access because they're doing contract work for manufacturers. They've gotten into that. I don't know if Google has gotten more open in allowing that, but in my opinion, if you can build a problem, all this can, you have access to the test tools to make sure the problems are compliant. The wider we can spread our test data, the better off we are. So this doesn't remote control; it just refreshes. So as I hit refresh, but I can't actually run an application from here. There's no. But I can reset the debugger. I can actually reboot the phone from here. There is an interface to remote reboot the phone. That's one of the things that you need to do also, is remote reboot. And most of the debuggers, most of the boot loaders that run on Android phones have the capability to look in the log of Flash for instructions. So when you run something like the ROM manager, it downloads your system, all your flash file systems you're going to need for an upgrade, sticks them out on your SD card, builds the set of instructions basically that you need to do in order to load those in flash, sticks them in the flash partition, then you reboot your phone and your boot loader comes up and says, there are instructions for me to run. And so it goes off and reads those steps, flashes all the file systems for you, erases the music area, loads the Google application, whatever the steps are, and then moves into your environment that you just loaded on the project. So it's fairly easy to do automated testing in this kind of environment, even if you're doing platform development. But the limitations for platform development is that the emulator itself doesn't emulate everything. Doesn't have hardware, doesn't have audio, doesn't have video. So actually, I think it does have audio. I haven't played with audio. I don't know how it
Make your comments about from the perspective of developing a Java app on the device. What's the richness of the system libraries and the documentation?
So Android, so the question is comments on the richness of the API in Android. I used to do MIDP application, which was the portable platform, and that platform was very restricted. Android is much richer than that. I've done Java development, graphical applications, not a lot, but some. Android is very similar to that environment as far as feature set, but totally incompatible as far as API. So if you've done embedded, and that's true also of MIDP. So if you've done a GUI application in MIDP, and you've done a GUI application on the desktop using Java, you haven't written anything that's going to help you in Android. The API, well, the language is the same, but the interfaces are very different. So the concept of an application with activities and views doesn't exist in any other platform. So there's a significant learning curve in walking through and getting your mindset into the way Android works. But once you get there, all the permission bits allow you to do things like talk to the accelerometer and talk to the audio and talk to, there's quite a bit of control there. Some things Google doesn't want you to do, and so they are protecting you. An example, somebody has it's a commercial application that was on the market, worked well up until Android 2.1, and then in 2.2, Google closed considered that a bug, and closed the interface that it was looking for and didn't publish or replace it. So any developers that were using that application on Android 2.1 and operating their phones 2.2 now found they paid for a commercial application that no longer was in effect. And Google says, we recently documented the API. In this case, it was actually documented, it's documented for. So it's up to Google what interfaces they publish or what they don't. So one example, I know a company that's trying to do basically an answering service on their phone. So they use Asterisk, right? You can go through Asterisk, you can go dial-up menu, it can answer, it can direct you all these different boxes, you can voicemail in multiple places, you can send an email, you can connect remote systems, you can do all these things on Asterisk device. But Asterisk is nothing more than that running a lunchbox. So in theory, you can take Asterisk, build an APK, launch the whole thing as a receiver system, a background service, and now you got Asterisk running on your phone. Well, one of the things that Asterisk does in order to be useful is it listens to incoming phone calls. That's not supported on Android. I can talk to the speaker, I can talk to the mic, but I can't answer the phone and talk to the phone without the user talking on the phone. There's no interface for doing that. There's no public interface for doing that on any device. There are a couple devices on the market that support it in software, but you have to go around Google's API to do that. And Google says, no, you shouldn't be able to do that. Because, and legitimately, they're worried about this, right? If I was to write, Angry Birds version 10, that would answer your phone for you and not tell you. Or, call all these spam, do telemarketing for you. And it's not exposed. You as a user might not see it.
Actually, it's more likely that apps in the market will still call when 100 numbers coming back.
And
900. Yeah. 900.
yeah. So it's the same thing, right? Through the dial control. Now an application can dial, but it can't take over ownership of that call. So could actually dial a 900 number and then show it on the screen. There is an API for doing
But
that.
then you notice.
But then you would notice, right? So that's, you know, so some of these things need a little more thought, right? If you've got strong feelings on how things should work and how you can protect the user while still pushing in some of these features, I'm sure there are Google people who want to listen to you. But on the other hand, if you happen to be a mapping provider who wants to do voice prompted navigation instead of doing Google Maps navigation, you won't work.
So one of the promises of Java is code wants to run everywhere. So in this case, it really is not feasible to have the same code base run on Android and on the PC, for example.
Other than in the right. Because the API for Android is not natively available anywhere else. Now, in theory, that APK is platform indifferent, right? So if you build CyanogenMod for an x86 larger tablet, you could have a different, you know, a native running environment from instead of running QEMU running. But I don't have an x86 environment installed here. Let me be brutal to my emulator and I'll kill it. But I do have, I've downloaded the development kit from Bronze and Noble. Find it on the screen. There you are. So here I'm going to launch a new color. All right. Having it. And this is running more or less. This is running the ROM that Barnes & Noble pushed down into the SDK. So it's not exactly the ROM you get on your node. It doesn't have the Barnes & Noble marketing, for example. But that's up to Barnes & Noble. They could have put everything in. And it looks more or less like, and they haven't done it. So, what should I do? You have one? What are you running? What?
Honeycomb.
Honeycomb? You're running the official build, or you're running Salmon?
One of the honeycomb demos is that there is no science yet.
No. But
There is no science yet. Honeycomb is Google offers the source code.
that's right. The official Salmon's report is still on Gingerbread because Honeycomb is not official. In fact, there are some hacks that combine these bits from Cyanogen and these bits from the commercial Honeycomb image and build replacement images. Anyway, there you go. So now it looks very different than what I launched before. Here the apps are included with that. I haven't really looked at what's here other than launching a web browser and it should have network access. Come on, no Barnes & Noble. I started Google. So as a hardware vendor, in theory, you can plug right into the Android development tools and provide people with the skins for your device, any proprietary libraries and runs through as part of that. It's a fairly rich environment for simulation. I don't know what question would let me into that. Okay, I'm going to ask you questions. How many of you have done at least one application built for Android and put on a device running it? Doesn't matter. How many of you have an Android device in your possession? See, we've got, we can get double more penetration on application builds, at least, than you have data devices to run them on. All the rest of you who don't have an application device are probably this track. You can run an emulator on your desktop, on your laptop, so that doesn't give you an excuse. Because like I said, you can download and run the emulator, and you can build even community builds to run these products. How many of you think you're going to do application development in the next 6 months for Android? How many of you are interested in doing improvements to the OS itself? Cyanogen logs, something like that. All right, good. That was the point. Get you wrong. All right, any questions?
This is the security stuff. The vendors seem very concerned that providing data code access is going to be a security issue for them. If they're trying to lock it out or something like that.
So security around Android is an interesting area. Google is very concerned with their platform being perceived as insecure because they're very concerned with getting out the door everywhere. And they're doing a great job of it, incidentally. The Android platform, but specifically that Android as a platform, is outselling iOS, Apple devices everywhere in the world now. There's only last quarter that they bypassed in some of the Asian markets. And they're still being outsold by BlackBerry in a few areas, but those will probably drop this quarter. So Android will be the number one selling mobile OS in every environment in the world. And that's coming from nothing in 2008 to dominant in 2011 is a huge accomplishment. So they're doing a great job. But there's been a lot of hand waving, and things only get addressed when they're real. And there are a lot of promised issues that haven't happened. I had a bunch of quotes in my talk. It was all ranting, and I took them out. But when Android released 1.6, is it doing it? No, it was cut. When they released 1.5, part of the press release for the 1.5 release, which happened probably, I don't know, 2009, late 2009, was a whole section on, we're not yet releasing our intro source for this, but we're going to move everything to our public repositories, and the next release should be public, and we're going to start working there in the community and getting community participation instead of working on our internal trees by the next release. Actually, I don't think the press release said by the next release. It said soon. So whatever soon means. But when you talk to developers, or talk to, that was the impression you get is by the next release. The next release was like a month later, which was Donut, as it shipped on the Droid, with none of the features that were in the Droid had really been talked about in the community. It was entirely an internal project. The Droid release never got released publicly, not just later, but never. And there's really been no progress towards moving on an external tree in the 2.5 years that followed. Year and a half. No, it's been over 2 years. As far as working with the community. So there have been security issues that the community has fixed. We found problems, holes in your device. We've been able to root it. Here's how we rooted it. Please fix this, because you want to. And those have taken 9 months to roll through Google's internal release schedule until they showed up on actual devices. For the 9 months, the community's happy because they can read all the phones. They're all in the same vulnerability. But some things have got to move on quickly. When they get pressed, they can move on quickly. When they don't, someone at Google asked them, and rightfully so, evaluate, is this important enough for us to spend time on? And their priorities are not the same as my priorities. So I'm displeased with some of their priorities, but I think no matter what they did, there would be people displeased with some of their priorities. Overall, there have been much fewer security vulnerabilities on Android than I thought there would be, because it has a totally different architecture. So it is apparently seeing decent testing, or it's not seeing enough people trying to exploit the security flaws. It's unclear which one.
C access means you're now outside of the Java sandbox. You have a lot more control, even though you're still running as a user content.
Right. So some of the recent kernel exploits are actually still exploitable on many of the Android devices, and that's how people are getting. There are lots of different opportunities. So because the vendors keep moving slowly, the security will still go longer. That's not Google's fault, because Google has fixed some of the important ones in their tree group. All right, my throat's dry. I think we all need a drink. I don't drink alcohol, but I'll take it. That's about all I want to cover. We're out of questions? I'm being
Okay, well, when applications ask for permissions to access certain things, how does Android security handle that? Is it like SE Linux? Is it SE Linux? How does that work?
No, it's not. It's not anything the kernel sees for most calls like that. There is an internal interface, for example, to ask for your own phone number, the phone owner's information.
Right.
Nothing at the file system that's there, that's just an API call.
Well, that seems
So
like
Android
it
specific
should
calls.
be in the file system, but it isn't actually. But that would be cool, that's what I was thinking.
Yes.
That would actually implementing that on Android, unless, I mean, I know there are a couple of things that are very similar to it.
Right.
But
So,
the problem with that
you're right.
is nobody uses it,
Right.
right? But it could work quite well if it was integrated in the phone system on the phone.
The issue was they didn't have bits that matched everything they wanted. They did actually look at SE Linux when they were doing the security modes, but they chose not to go that route. AppArmor was not around at the time. It has some advantages and disadvantages that might have been something else that we consider, but it wasn't really visible enough to time to make a decision. So right now it's its own stuff. So some things is directly mapped to getting permissions like access to /SD card.
Right.
That's owned by I forget the name of the group, but it's owned by the storage group.
So it's
And
not,
your
it's
app
not
is
going to
individual
use
to
your
yours. Right.
So is everything done that way?
No.
No.
So some things are things like getting the phone owner's permission. There's an API call for that, and it's internal to Android to check that permission. So it's a mix.
Okay. This sounds a little messy from what you're describing.
It is a little messy, but that's because if you look at the 30 some odd permission bits there are, they don't all map to files. It's not even something that a context in SE Linux would cover.
Okay.
Because it's not all executing something or accessing something. It's in many cases, I'll give you these fields out of the SQL database, but not those. Well, that's not an SE Linux permission, even in an SE Linux machine. That's an SQL permission that would two different users should access the database.
Yeah, I'm not sure. I think it could be.
I don't know of a way of mapping SQL field access into SE Linux.
It's got to be a kernel call or, yeah.
Because you can access the database.
Yeah.
Your contacts can open the database.
Well, then you would do that with permissions. Yeah. So
Exactly.
that's what permissions for.
Exactly.
For a newly written application, what version of the iOS would you recommend write on for usable?
So there's only one currently shipping 1.5 Android device that I'm aware of, and nobody likes it. So I wouldn't worry about anything 1.5 Android. There's only about Android tracks some stats on their site. I don't remember what the latest numbers are, but I'm going to guess somewhere around like 25% of our data is 1.6, and 75% and up is 2.1 or newer. 2.3. Well, there have been 3 releases of 2.3, so I don't know if they track those independently. But if I was writing an application today, I would target 1.6 where I have no reason to target anything else. And if I like to need the newer APIs, I have gained and I can use the better acceleration, or I can use whatever it is, I would easily drop 1.6 off the list and go to 2.1. If it's going to give you significant improvement. And if you're going for a tablet, then you really ought to be in 3.0. So that's my mix. 1.6, 2.1, or 3.0, depending on I wouldn't spend a lot of time doing 2.3.1 today. Yeah, even if there were finding some really compelling feature would drive into 2.3. There just hasn't taken over the market yet, and I don't think there's that much that I've seen that's significantly different. But one of them is, if you wanted the native applications, and indicate that the context on the screen, that would be a compelling feature. Yeah, you want to do 2.3. If you found some blocking feature like that, do it. But realize your smaller market set. For the higher you raise the bar, the richer the API, but the smaller the market set. So you got to decide, I'm going to sell more here. If I've got to totally recode an application in Java, I'm going to ship on 2.1. And I can, I've got my native application I can ship on